Hello, welcome back to my video. My name is Ayush Kumar and my USN is 1VE23CS022 and I am from second semester and my section is Audi. And today's subject is CAD, which is basically Computer Aided Engineering Design. Our subject teacher is Suresh DB sir. So let's get started. So first, introduction to Computer Aided Engineering Design. So CAD is a powerful tool that uh, enables the engineers to design, analyze, and optimize the product and system using advanced software and hardware. So CAD streamlines the design processes, improves efficiency, and help creates the innovative solutions. So today mainly we are going to solve on three main topics, which are basically planes, lines, and points. So let's get started with planes. Planes. So planes in engineering design, which includes like planes are fundamental building blocks in engineering design, which represents the flat surface that defines the boundaries and shapes of components and assemblies. For example, like triangles and pentagon. Next, we have planes are used to establish coordinate system, which provides a frame of reference for defining the position and orientation of objects in 3D spaces. Next, plane helps define design constraints, ensuring component fit together and function as intended within the overall system. So now you have a problem based on planes. So the problem is as it goes. So an equilateral triangle, which has a lamina of 25 mm side, lies with one of its edge on HP, which is horizontal plane, such that the surface of the lamina is inclined to HP at 60 degree. The edge on which it lies is inclined to VP at 60 degree. Now draw the projections. Let's get started. Let's continue. So first what you have to do is draw a XY line. First you can go and select the line. Here you can select thickness, which is 0.35 mm. Then you draw the line. Then you can name the line, which is basically the XY line, X and Y. Next, what you can do is, according to the question, now you have to draw a triangle, which is equilateral triangle. First, we'll get the length as 25 mm and the angle as 60 degree. It's it here. Next, we'll give 25 centimeter. Then we'll give minus 60. Next, we'll give 25 mm again. And but this time the angle would be 180 degree. So there it is, equilateral triangle. Next, what you have to do is like you have to move this a bit. So you can go to the move option. Then you can select it like this, and you can select that and you can place it wherever you want. We actually need a reference point for it. We can't actually directly join the thing with the XY line. We need a bit of distance, which is why we'll use a reference point for it. Next, go again there and select the rotate option. Then you choose your diagram. Then select it like this, and you can rotate the thing. As you can see, it is done. So next, what we will do is we'll just join the line with the XY line. But here the line should be 0.13. So next, what we'll do is we'll measure the, okay, before we do this, we'll just slice it off. So you have to measure actual, like what is the total length of it, which is 25 mm. Now you can again join back the thing. So now that is done. Now you can add, here there is an option called leader. You can just use it and show like which towards which direction it is being drawn. Now you can actually name them, which is basically, you can name this as E. For a better view, we can also do it in this way. So I have named it as E for this point, and always it will go anti-clockwise. So it will start from here and it will go till here, then this. So now we have ABC, all the 3 points. By the way, the line above this is a vertical plane, and the line below the XY line is a horizontal plane. We'll just mention that VP and HP. So as this is done, then we'll draw a 60-degree line from here, which should be again 0.13. Like this. Sorry, again we'll do. Yes. So here we can select this as 0.13. and take it from here. Next we can draw a 60 degree. Length can be how much ever we want, but the angle should be here at 60. So from here, first you have to do is you should show what is the angle between the thing, just for the confirmation, which is 60 degree. Now here what you can do is you can actually name the parts here so that we could reflect the same thing on the 60 degree line. You can name them by like if it is above the if it is above the horizontal plane, then you can name it as basically b dash into e dash. Here you can name it as c dash. So there is an option for it. So next what you can do on the point, yeah. So next what you can do for the radius, you can put 22.09 and you can just enter. Now you can cut the arc. I can extend the same line. You can actually zoom it more for better viewing, like this. We'll just extend the line. Till there, we have got a basic structure for it, so that we can draw. We can actually extend it more up to here, and we'll just cut these lines which are not required for us. So next we'll continue, and we'll just extend these lines from here up to here, and we'll also extend these lines from the point A to here. Next from here to here, and here to here. Now we'll just join these lines. Uh, always the thickness of the line should be always at 0.13, but for these lines it should not be 0.13, it should be 0.50. So we can change that by selecting either the single lines or all at once. Those things should not be missed. Those are very crucial for the understanding. So first we have marked the angle. Now the next thing which we are going to do is we are going to show the leader. Using the leader option, we can show from which side to which side the line is being extended. This and like this. Here basically basic structure is being done. Now we can also name these things, which is basically over here, which is basically A, this is C, this is B. Now next we can extend this line and it should be 0.13 mm. To some extent we can draw. So next we have done this. Then according to the question we should draw another 60 degree below the VP. Now the next what we are going to do is we are going to draw a 60 degree line. We'll take from here. So the length will be how much ever we want, we'll put 60, and angle we are going to put minus 60 just because it is below the quadrant. It should be like that. Next we are going to measure this thing just to be sure that we are not wrong. That is 60 degree again. Now what we'll do is we'll take a reference point. Reference point should always be 2 millimeter. We'll take the reference point, then we'll come back to the line, and here we'll just give 0.13. Next what we'll do is we'll move this triangle. So for moving this triangle again we have to use the move option. Then what we can do is we can copy this and paste it over there. We can erase extra lines, which is basically this. We can also remove this. So next, after that, what we can do is we can rotate this. From here to here, and we'll just rotate it. As you can see, the triangle has been rotated. Now what we can do is we can extend all these lines. It should be 0.13. We can extend this line, which is also 0.13. Now let's extend this line, this is also 0.13. Now next what we can do is we can name them, such as A, B, and C. And we can show the side at which they have been taken by either option. like that. Now, uh, one of the lines should extend all the way to the top. Is this line over here? Sorry, a line has been a mistake. We'll take this, leave it till there, and see, this line should be at 0.5 mm thickness, thick line. Next, we'll just try to join the line like this. This. Again, we have to make sure that these lines are 0.5 mm, like that. And now we can erase all the extra lines. Show the leader line. Basically, show the direction at which from it is coming. And next, we'll take the trim option and we'll just remove the lines which are not required. And next, what we can do is we can name these, which are basically above the line, so it will be C dash. And here, this one could be named as B dash. This one could be named as C dash. This line should be 0.5 mm, like that. So, and also this line also should be 0.5 mm. So here we can choose it like that, and we can make it 0.5 mm. As you can see, the thing is done, and that's how you solve a problem of planes. Points. So points in engineering design. Points are used to precisely locate and position elements within a design, acting as a reference point for other features. It also used in intersections and as well as geometry control. Now we have a problem based on points. As you can see at the bottom of your screen, draw the projection of the following points on the same XY lines, keeping convenient distance between each projection. Name the quadrant in which they lie. Point A 30 mm above HP and 35 mm in front of VP. Then point B 35 mm above HP and 40 mm behind VP, and point C 40 mm above HP and on VP. Next, point D 35 mm below HP and 30 mm in front of VP. Let's continue with points. So here, what you need to do is first go here and select 0.35 mm and you draw a line which should be exactly straight. Next, you go there and you name it, which is X, and this is Y. So next, what you can do, according to the question, at point A, it should be 30 mm above HP and 35 mm in front of VP. So first, you go to the line, select 0.13 mm, and you go and draw a line which should be 30 mm above HP. So length 30 mm and angle should be 90. It is fine. Now to measure whether this is correct or not, you can use this smart dimension and you can measure it. It is 30 mm, which is correct. And you can go here and you can choose the length, which is 35 mm below VP, sorry, in front of VP, and you can select this. And next you can go to the smart dimension and you can select this. After that, go to this option, which is text option, and you can just name it, which is A dash, because it is above the XY line, and this is the front view. For the better view, we can just zoom in, and yeah, again we'll go to the same point. From here, both will come. The first one should be 35 mm and 90 degree, and you can measure it just for the surety thing, 35 mm. Then you can draw another line which is on this thing, which is 40 mm, and the angle should be 90. So next you can also measure this line, which is like this, 40 mm. Next you can name these lines by going to the text option. Then you can just name it, which is this, and next what you can do, just extend it, length 40 mm, and this thing for the point C, and you can use a smart dimension, and you can also name them for the point C, which is C from top view, and here, which is C dash, because it is above the XY line. Next, for the fourth point, which is D, 35 mm below HP and 30 mm in front of VP. So for that, what you need to do is you have to draw two lines which should be below the XY lines. The first one should be 30 mm minus 90. So you have to draw another line, always 0.13. Next from here. If you before you do that, you can do the smart dimension thing, just to be sure. Next after that, draw another line. It should be 35 mm and 90 degree. Now you can also measure this with smart dimension, just like this. You can also name them D, top view, D is front view, D dash is front view. That's it for the problem. Next we'll continue with the other problem. So we have a problem based on lines, which is basically a line AB 75 mm long, and it is 30 degree and 40 degree inclined to HP and VP respectively. The end A is 12 mm above HP and 10 mm in front of VP. Draw the projection line in the first quadrant. So line is 0.35 mm. We draw this, take this, limit as X, limit as Y, and here what we need to do is like 12 mm above the XY line, we have to draw a line which is basically the off. We can use the offset material, and we can use it. It's 12 mm. We can use the offset material over here. So next, now here it is a 12 mm offset which is created. You can also measure this. You can take a smart dimension of it. It's a 12 mm line. So here next, we also need a 10 mm line. So what we will do is we'll take offset of 10 mm. So here we'll take off offset line and join it here, and we can check whether this is actually a 10 millimeter or not. It is a 10 millimeter line. So next what we can do is we can draw a 75 mm So after we take the smart dimension of this thing, we have to replicate the same thing on the other side. But here the angle should be at 40 degree, 75 mm and 40 degree. So sorry, but the 40 degree should be at negative just because we are below the XY line. Like this. Next we'll take smart dimension of this thing, the 75. We'll just draw a locus on it, like this. We draw another locus on this, which is like this. Now what we'll do is we'll extend these lines. A true length line should always be till there, and we'll also extend this line till there. Next what we'll do is we'll take arc by center point. We'll keep the arc over here. We'll take it from there. We'll cut the arc, and we'll do the same thing from here. We'll take this. We'll cut the arc somewhere over there, and at the point where they meet, we have to draw a line from the point. From here to that point. Now we have to use a smart dimension, and we have to measure it, which we have got 57.38, and for this line, which is 60, 64 to name them, which is this is B, this is B dash, and next over here we have this as B, and this one as B, and over here we are going to name it as A. Next we are going to show the leader lines, which is basically at what point it is being done. that. So that's it for the problem. But there's one more thing, which is basically we have to also measure the angle from here. So just 40 degree, and so that's it for the problem. I hope you like the video. I had all and then most of you, some and now none of